Hi, I'm RL from MathinSG.com. In this video here, I'll be going through the H2 Math A-Level paper 2024 paper 1 question 3. So question 3 is is a complex number question. So in this question, you are given the equation z cubed plus az squared plus bz plus c equals to 0, where a, b, and c are constants, has roots 3 and w, where w is a complex number. So you are asked to state a condition on a, b, and c for the third root to be w conjugate. So what do we know? Whenever we have an equation or polynomial equation and all the coefficients are real, then the complex roots must exist in conjugate pairs. So in short, in order for a, b, and so for the third root to be w conjugate, that means this equation here has the roots of both w and its conjugate. It means that a, b, and c must be real. Okay, so this is what you need to write. They are real. Okay, so now given that the condition in part A holds, that means a, b, and c are real. So therefore, we have the roots of z equals to 3, z equals to w, and z equals to w conjugate, and w equals to minus 1 plus 2i. Find the values of a, b, and c. Okay, so now we have three unknowns, right? A, b, and c. So we need three equations to solve them. So let's first form the first equation. We know that when z equals to 3, this equation is satisfied, right? So we know that 3 cubed plus a 3 square plus 3b plus c equals to 0. So we form the first equation. And we know that we'll use our GC to solve systems of linear equations. So we'll arrange it in the form that is easy for us to type into the calculator. So I put the number here, 27, to the other side. Okay, and label this as equation 1. Next, I need to find b, right? So let's do it. So I know that when I sub in b into this equation, if I sub in w into this equation here, it must satisfy this equation. So let's do it. Okay, and this question didn't say that you cannot use your graphic calculator. So please type minus 1 plus 2i cubed into your GC to evaluate what it is. Type in minus 1 plus 2i squared into your GC to evaluate what they are. Okay, don't do it yourself. Okay, it's not worth the marks. It's just 3 marks here. So once I type it into the calculator, I know that this is minus 1 plus 2i cubed is 11 minus 2i. Then this one here, minus 1 plus 2i squared is minus 3 minus 4i plus b minus 1 plus 2i plus c equals to 0. Okay, so now let's expand everything. I will get 11 minus 2i minus 3a minus 4ai minus b plus 2bi plus c equals to 0. So since all the coefficients, right, are real, so I know that the real is, I can equate real equals to real, or those numbers without I to be equal to each other, and those numbers that have I will put them to be equals to each other. So if you look at this part here is 0, right? So it's actually 0 plus 0i, right? So I know that 11 minus 3a, okay, minus b plus c, these are all the real ones. I've underlined them. They are equals to 0. Okay, remember we are going to use the GC to solve for a, b, and c. So I need it to be in the form where the GC can read. So I'll rearrange it into 3a plus b minus c equals to 11. That's my equation 2. Then again, the imaginary part is equals to the imaginary part. So here is 0, right? So, or 0 plus I, right? So all those with I must be equals to 0. So let me form another equation. Minus 2 minus 4a plus 2b equals to 0. Okay, again, let me write it in the form that is easy to type into the GC. So 4a minus 2b, that means no c, is equals to I bring this over, minus 2. So that is my third equation. So 3 unknowns, 3 equations, great. So I can now use the GC to solve. So by GC, I will get A equals to minus 1, B equals to minus 1, and C equals to minus 15. Alright, so this is the answer for question 3.